Here are some examples of problems about rational equations and functions. Problem 1. Solve the equation 2 over x equals 5 over x plus 3. First, let's write this equation out. 2 over x is equal to 5 over x plus 3. Notice that this equation is actually a proportion. This means we can cross multiply. On the left, we'll have 2 times x plus 3, and on the right, we'll have 5 times x. If we simplify this, we get 2x plus 6 equals 5x. Now subtracting 2x from both sides of the equation will give us 6 equals 5x minus 2x, which equals 3x, since the 2x's on the left side will cancel. Finally, dividing both sides of this equation by 3, we get 6 over 3 is equal to x, and 6 over 3 equals 2, so x equals 2. Just one last thing, we need to make sure x is not an extraneous solution. So if we plug 2 in for x in our equation, on the denominators we'll have 2, and 2 plus 3 is 5. Neither of these are 0, so we're okay. Problem 2. Solve the equation 4 plus 2n over n equals 3 over n minus 6. First, let's write out this equation. 4 plus 2n over n is equal to 3 over n minus 6. We want to turn this into a proportion so that we know how to solve it. But to do that, we need to turn the right side into a rational expression from the mixed state it's currently in. So 3 over n minus 6 is equal to 3 over n minus 6 times n over n. Now both terms have the same denominator, and we can combine them to get 3 minus 6n over n. So now we have 4 plus 2n over n equals 3 minus 6n over n. In this case, we don't even need to cross multiply. If we multiply both sides of this equation by n, then the denominators of both sides will cancel, and we're left with 4 plus 2n equals 3 minus 6n. Now if we add 6n to both sides of the equation, we have 4 plus 2n plus 6n equals 3, since the 6n's on the right side will cancel. So 4 plus 8n equals 3. Subtracting 4 from both sides, we get 8n equals 3 minus 4, which is minus 1. So if we divide both sides by 8, n is equal to minus 1/8. Now plugging minus 1/8 into the denominator of the original equation's terms is not going to cause any problems, since n is not equal to 0. So this is not an extraneous solution. Problem 3. Find the roots and excluded values of the function f of x equals x squared minus x minus 12 over 4x plus 3 times x plus 1 times x. First, let's find the excluded values. Now, excluded values are values where the denominator is 0, so the function is not actually defined. Since the denominator of this function is already factored, we can easily figure out when it's 0. This happens when x plus 3 is 0, when x is equal to minus 3, or when x plus 1 equals 0 at x equals minus 1, and at x equals 0, which is at x equals 0. Now let's find the roots. The roots of the function f are all the points x at which the function f takes the value 0. Now since f is expressed as a fraction, we know a fraction can only be 0 if the numerator is 0. So the equation we want to solve is x squared minus x minus 12 equals 0. To do this, we first want to factor. So this can be written as x minus 4 times x plus 3 equals 0. Since minus 4 times 3 is equal to minus 12, and minus 4 plus 3 is equal to minus 1. This gives us roots of x equals 4 and minus 3. But wait, minus 3 is an excluded value. This means that the function f doesn't even exist at the point minus 3, so it can't be a root. So let's get rid of this. That means the only root of f is x equals 4.